Hi guys, this is your learning coach Vinod, and so happy to meet you all today in a webinar. Okay, amazing.
Super, guys. So today we have a very important guest with us. So we have Dr. Sivasubramanian. So he's a former scientist, senior scientist at ISRO. So he has been working in different functions as a consultant and also as a honorary visiting professor. So he has actually had about 40 years of experience working in ISRO, and right from 1969 to about 2009, he was with ISRO, and he has been responsible in building rockets, launch vehicles, and satellites to bring self-reliance to Indian space program. He had been a senior scientist there as a project manager, as a project leader, as a contract manager, and a chief general manager during his tenure out there. And he has also had been a very close confidant of our former president, Dr. APJ Abdul Kalam. So without further ado, let me bring Dr. Sivasubramanian online right now. Sir?
Yeah. Good evening to the organizers
Sir,
as well as...
Your voice is not audible, sir. Can you mute it again and talk?
Yeah, but I'm not getting only
Can you
four
mute it,
parties.
unmute it?
I don't know. Somebody is very slow. System is very slow.
No, sir, still not audible.
Uh,
Okay, I think you are audible right now, sir. Yes, sir.
yeah, now it's audible. Yeah, system is slow and bandwidth is slow. I don't know.
Sorry, sir. So you are audible right now, sir. I'm so sorry. So thank you so much
Okay.
for being here, sir.
Okay. Now the PowerPoint, the slide is not there, you know?
Yes,
It's
sir.
not
I'll
visible.
bring the slide right now, sir. I'll bring the slide right now. So let me just give I'd be really happy if you can give a little bit of information about yourself. I know that I'm
Okay.
not even young enough to, I'm not even old enough as your experience with ISRO. So I don't think it is kind of like, right for me to tell about all the things that you have done for our country. So we'd really appreciate if you can just share a few words about yourself, and then we can just get the session right away, sir.
Okay. Shall I go ahead?
Yes, sir. Please, sir.
Are you audible and visible?
Yes, sir. Fantastic.
Okay. Good evening, students and organizers of the session webinar. I'm Dr. Sivasubramanian. Right now in Madurai, but I worked in Indian Space Research Organization for 40 years, as Mr. Vinod mentioned. I had a qualification in BE Mechanical Engineering and subsequently Management Studies MBA and a doctorate in postdoctoral research. And I have done a couple of research papers and guided students both in postgraduate as well as doctorate degrees. And I worked with Dr. Abdul Kalam for 15 years of my service of 40 years. And I was a close associate in his projects as a project engineer or project manager and contract manager, chief general manager, responsible for realizing the rocket system. And subsequently, under his guidance, and we jointly worked, Abdul Kalam and myself jointly worked for certain social projects, which fetched me certain recognition from the government of India in terms of National Development NRDC Award and Outstanding Scientist Award, Best Metallurgist Award, and Lifetime Achievement Award. In two words, I have to tell means the instruments which gives the direction of the rocket and satellite, where it goes and how it goes and what speed it goes. That's called gyroscopes and instruments. That was indigenously made by me and given to project to Dr. Abdul Kalam. wherein I had a contact. And subsequently, not only instruments, but also materials for required, special materials required for the spacecraft and the satellite. At the last, and I worked for cryogenic engine, which gives a heavier thrust for the satellite launch vehicle to put a heavier satellite, about 4,000 kilogram satellite, into sun synchronous orbit. That the engine was technology acquired from partially from Russia and partially indigenous, and I delivered the engine. The last part, last and the least part, uh, I contributed something for the Chandrayaan 1, the Chandrayaan spacecraft, which went to moon during
Yes, sir.
2008. 2008, wherein I have supplied small rockets, as well as the last part is as per the advice of Dr. Abdul Kalam, the national flag, Indian tricolor national flag was realized by me and fitted in the Chandrayaan. So my contribution lies in lunar
Still there.
surface right now.
Yes, sir. It's
So
still there.
still there. So that was my last contribution. Subsequently, I moved to southern part of India. My main intention was that Abdul Kalam has met to 4 crore students and youth. I traveled with him for some time, and I met something like 4 lakh people right from south as well as north. And I delivered many lectures to motivate students so that India becomes a strong nation by 2020 this year. So that was the motive, the idea. So higher education to the students, higher education and the knowledge, and how to improve their skill, and how to orient their courses to carry to the appropriate courses. That was guided by me, and I was, to some extent, I was doing as a honorary professor in some engineering colleges for research work. Some of the research work I helped to carry out. That is a background, and society also I have improved my education standards. So this is my background. With the background, I will start my theme of my talk is
Yes, sir.
space technology. Is it okay, my introduction, or you
Yes, sir.
need someone?
Yes, sir. Yes,
Uh,
sir. We are actually very happy, sir. So the entire team family over here at Space Science Learning Club is so happy to have a person with so much of experience and so much of commitment to giving back to the children. I just called you up. You do not know me. I just called you up and asked you for a favor to be here for the kids, and you agreed instantly. So thank you so much for that once more, sir.
so so today my talk is space technology, which will improve the life expansion. Uh, that is our living condition. Uh, in fact, October 4th to October 10th is called a Space Week because October 4th, 1957, first Sputnik satellite was launched by Russians. That was an object which went out of the planet and circled Earth. That was the first satellite. So, and October 10th was the another occasion wherein the International Space Organization treaty and other thing has been worked out. Hence, this 4th to 10th, they celebrate Space Week all over the world, where whomsoever the spacefaring nations. So, in India, in the Indian Space Research Organization, we celebrate the Space Week in all the centers of ISRO, right from Bangalore, Trivandrum, Sririkota, Mahendragiri, Hyderabad, Ahmedabad, Delhi, Lucknow, wherever the center is there. We celebrate the week by conducting the quiz program, seminar program, as well as the organize an exhibition, space exhibition we organized, by which students can participate. Last year, I organized here at Madurai. Last 2 years, I organized at Madurai. and more than 50,000 students all around in and around Madurai visited and had the flair of what is space technology. So, in this connection only, even now Trivandrum is conducting quiz and seminar program for the students, and we encourage students to be aware of the space, what is the benefit of space to the common man. That is the main motto of this one. So, our space for Indian space program started as early in 1963 by Dr.N Sivasubramanian, and he had the vision that the we must be second to none in the among the developed nation, and the benefit of the space technology should reach to the common man. That was the main vision of the great scientist. He is the father of the Indian space program. He basically is a researcher in cosmic rays. Cosmic rays, he worked during 63, 69, and outer space exploration, outer space, what is happening. That was the research. So he formed he started the space program, and initially he started working in Trivandrum, Tumba Equatorial Rocket Launching Station, in the western coast of western bottommost part of India. And 1968, Prime Minister Indira Gandhi dedicated the center for the United Nations so that it is useful for international space agencies to have their experiments. So we started with only sounding rockets. At that time, we didn't have the rockets, and we had to borrow the rocket from Russia, America, Russia, and France. The first rocket it went from Indian soil was the Nike Apache, an American rocket, which went from Tumba, Trivandrum, went to a height of about 80 kilometers, and the upper atmosphere experiments have been done. That is, you go up to the 80 kilometers, the rocket will have the payload, which had instruments, telescope, and spectrometers. So it measures the cloud and what is the alpha rays and the cosmic rays. That it measures and it falls in the Arabian Sea. So that was the starting point of the Indian Space Research Program. But in 1968-69, whereas the developed nations have gone far ahead of us, and they, in fact, 69, they landed in moon, and they sent a person to moon, and they first man to reach moon was made in 1969. So we were something lag behind due to our we were a developing nation, and our search and slightly far behind. So, and from 69, we were putting a sounding rockets, and then now in 2018, we were able to, in the span of 60 years, 50 years, we were able to put our spacecraft or probe to Martian red planet. During this 50 years, we were from western coast to red planet. We are able to move because of dedicated work and concentrated work on the space research. So, with this background, the space research, as already I have
Sir, I
told.
actually have a small question. Can I interrupt you right now?
Okay.
Yes, sir. You were telling that the initial days, India used to, get the rockets from US and Russia to run it.
Thanks.
So you get the fully commissioned rocket, or you get it in parts and then you assemble it here. Like, how was those kind of experiences, sir? Like,
We were getting initially totally filled up condition.
okay,
It's a filled up condition. We were launching it till 1969. We
uh-huh.
got a technology from France. There's a rocket called the Centaur,
Okay,
French rocket. We were, first few numbers we got, and as a compensation, they gave the technology. Then we made
okay,
we indigenized that rocket, Centaur rocket, in Indian
uh-huh.
soil. at Bombay as well as in Trivandrum and Jamshedpur everywhere. And we made the first center rocket center launched in 1969 from Tumba rocket launch station. So that was the condition. That was a total indigenization program launched by Sarabhai.
Okay.
Dr. Sarabhai launched the indigenization program for which whatever material required, whatever propellant required, whatever fabrication required, everything we learned by ourselves. And
Okay.
we made ourselves. And there's a specific material, French material called 15CDV6. That's a steel material. We were not knowing, only we were knowing the specification of the composition, which we realized in our Jamshedpur and Rourkela, and we realized it material to the quality, to the specification. Similarly, the propellant also we made our own propellant, and the propellant plant we have set up. So in Trivandrum, we had three such a unit. One is rocket fabrication facility, which was making only center rocket, manufacturing, rolling, welding, testing like that. Another thing is rocket propellant plant. That is the propellant cast. It is oxidizer and fuel mixed together, and it is mixed, and it is cast into rocket propellant plant, RPP. Then the casing is filled with propellant, and the third center is rocket launch center. That's called TERLS. That is the sea coast. So there we take it, and we have the instrumentation and the control monitoring at the control center, and from there we used to launch center. Whereas Nike patch was slightly smaller one, which is the diameter of 75 millimeter to 100 millimeter, whereas the center we made up to 300 millimeter diameter. So it could go up to 80 to 150 kilometers to the with a capacity of around 80 kg payload it could take. So that is the sounding rocket, just like it goes to the upper atmosphere. It sounds the environment. What type of cloud is there? What type of stream of cloud movement is there? What is the vapor condition, and what is the atmospheric cosmic ray or infrared ray? What is the particles? How many particles? Such a measurements you are able to do. So those measurements were done by the scientists, space scientists. They are the real space scientists. They are the real space scientists. The scientists from Ahmedabad, EAFR, and Physical Research Laboratory, Tata Institute of Fundamental Research. Those scientists wherein Dr. Sarabhai was chief. So those scientists came down to Trivandrum, made their instruments, and they give it to us for putting it in the rocket. Those instruments go to the upper atmosphere, and they did the mission. That is how the space system starts.
Fantastic. So we can go ahead with the, yeah.
So the first part of this thing is, as I said, any space program, students should understand, it has three components. One is space research. That is what you are doing the research in the upper atmosphere. Upper atmosphere, beyond your atmosphere, stratosphere, lithosphere, what is that? You have to do the exploration. Yeah, for any human being, exploring the unknown thing is the eagerness. That is that normally for any human. Yeah, for a scientist, it will be much more. So beyond the atmosphere, what is that? To explore. We put these instruments, as I said, these three organizations. They make the instruments and they observe what's happening in the upper atmosphere. That's how this space science research. In which that is a space science. Real space scientists, they are only those people they do the research on the upper atmosphere. Once you to go to that upper atmosphere, you have to have a small rocket. These rockets put the instruments in the upper atmosphere and fall down. The instruments carry out the measurements and they communicate to the ground station by telemetry, like radio signal it gives. But to go beyond 180 kilometers, to go beyond 180 kilometers, to go to the further at altitude, you need to have a powerful rocket. So, the first part is space science research by the instruments of the space scientists. To take the instruments to the upper atmosphere, we have to have a space transportation system that is called a rocket. Rocket, a powerful rocket, which carry the instruments to the upper atmosphere, and the rocket, after doing the purpose, it falls down. This rocket research is the second part. First part is space science. Second part is space transportation. But the instruments cannot be put in the rocket simply on the payload. It has to be put in a container, a instrument that's called a satellite. That's called a satellite or spacecraft, we call it, wherein the instruments are put. And this satellite is put in the top of the rocket, and the rocket pushes the satellite to the upper atmosphere, so that the satellite remains in the upper atmosphere and do the experiment. So, as I said, there are three parts. One is space science, space transportation, and the third one is the satellite system. And this satellite system is another science. So, these three put together started in 1974 research. And the first project was we started the first satellite of our own satellite, Indian own satellite was Aryabhatta, which was launched from Russia. We made the satellite and went to Russia. Russia launched the Aryabhatta into the orbit. Second, we sent Bhaskara, another satellite, which is going to a height of something like 500 kilometers above the Earth, and it circles for a period of some time till it does the function. So this is the first our attempt. Then only our space research program took a shape in government of India, and they said instead of sending instruments only for space research, only for space science, why not you do it for a common man application? So we wanted to put it to for the communication purpose, and the communication means telephone and television and meteorological purpose. We wanted to put a satellite called INSAT. INSAT satellite, Indian satellite. First satellite we call it Apple. Apple satellite. It is weighing around 1,800 kg. Was launched from French Guiana by French rocket. That was made much later, in somewhere in 1783 time frame. So that was the first step. We put three instruments. One is a television channel, and another one is a communication channel, that is a telephone connection. Third one is meteorology. Three put together, we put satellite. So it started functioning a first model, prototype model. Then we started our building we were increasing our enhancing the capacity. And we were first in the research and development phase. Then we became an operation phase. Operation phase means we are making a satellite, we are making a rocket and putting it together and putting it in the orbit. That is the operation. Then we made it in a production mode. That is continuously we are going on sending the rocket, and the rocket is sent through rockets, rocket and satellite integrated together. We are making a total system. That was the first mission. So at the time only, Dr. Abdul Kalam started the first SLV3. SLV3 was the made first designed indigenously designed satellite launch vehicle, and a Rohini satellite. Put it in Indian soil. From the Indian soil, it went to the orbit. That is the totally from indigenous. We reached in 1979, for which Abdul Kalam was the project director. So wherein our instruments are being flown, which calls for the direction of the satellite launch vehicle and how much it goes, what speed it goes, which, how far it goes. Wherein my role came into picture. So from that only we had the close interaction with Dr. Abdul Kalam from 1973 or 70 onwards. 70 onwards we had the close relation and we were making the instruments for the purpose. So we were putting the rocket first. So the three parts I will explain one by one. First I will go to the satellite part. Spacecraft for various purposes we are making. One is Earth observation system. Second one is a remote sensing system. The Earth observation system means in the Earth, if the satellite goes at the altitude of around 400 kilometers in a polar orbit, that means north to south. The satellite will be traveling at 400 kilometers above Earth from Kashmir to Kanyakumari. By the time Earth rotates. So it makes the one orbit in 90 minutes and it takes the picture of the Earth and it gives. So the movement of the arc, movement of the any any object, even building or in a structure can be measured. It will be observed and it gives the signal to Earth. There is one such a system that's called Earth observation system. And the second thing is remote sensing. The remote sensing, it means a camera is fitted in the satellite. When it goes over the continent, it takes a picture on an infrared IR region, so that uh, the the application like agriculture, forest, fishery, and the disaster, those things can be monitored by remote sensing, and it can give the signal to the ground. Third one is a surveillance, that means and a disaster warning. The movement of the army, the movement of our army force in the borderline can be monitored, and the disaster warning. If a ship is stuck at sea, what is the condition? This can be monitored. This is the remote sensing polar orbit, low Earth orbit. That is 400 to 500 kilometers. It goes from north to south. Another type of satellite is sun synchronous orbit, which is placed above the equatorial plate at 36,000 kilometers above, rotates along with the Earth speed. Earth rotation is 15 degrees per hour. Same degree, same rotation it goes, so that it remains in the same spot of Earth. That means if the satellite is placed above Nagpur, when the Earth is rotating, the satellite also moves in the same direction. So at the time, we can make a communication. Communication means a program planned in a Nagpur can be sent to the satellite and which can beam back to Earth for the entire nation. That is a communication satellite. Another one is navigation system. Navigation system is something like where you are, like GPS, global positioning system. Function can be done by a spacecraft system. And next one is weather monitoring system. The movement of the cloud, how far the cloud is moving, how the cyclone is formed, how the torrent, how the cyclone moves towards which direction. Those things can be monitored by certain instruments, radiometer, synthetic aperture radar. This thing can be put in the spacecraft and which measures and gives the information. So these are the things they call the spacecraft system, and it does the work. If you see the for the students' purpose, I'm telling the satellite is categorized by its inclination about the Earth. Earth is this, and the satellite is rotating in the red line, and the Earth rotation is the red line. And if this is same plane, there is one. If it is the equator and same plane, there is no inclination. For the polar orbit, it is going, as I said, north to south. There are some satellites which goes in the inclined orbit. Like inclined orbit means the inclination with respect to the equatorial plane. With respect to the equatorial plane is inclined orbit. by terms of inclination, a satellite orbit or satellite condition can be defined. Another one is the shape. Either it rotates in a circular orbit or it rotates in an elliptical orbit. These two types, based on shape, also we can categorize. Third one is, as already told, altitude. Whether it is 160 kilometer or it is about 10,000 kilometer or 36,000 kilometers. What is the altitude which it is going? If it is at 36,000 kilometer orbit, from here it covers the entire our geographical condition. It can give the beam. So these are the different type of satellite position. To reach that position only, we need a rocket. If the rocket, the satellite is in the particular orbit, say the circular orbit, there's a term called escape velocity. This is the satellite. These are the instruments. This is the antenna which communicates to the earth, and this is the total power system and other thing. This is a observatory. For the student purpose, again I am telling, there's a term called escape velocity. A satellite, it's a circular path, means at an altitude of 200 miles, that is 320 kilometers, it has to go in 29,000 kilometers per hour. Per hour, it should have the speed. The speed should be that much speed. How do you get the speed? If you throw a stone, it goes to a height and it falls down. If you want to throw much further, you have to have a larger force. If your force is much more thing, it will go on rotate. This is a simple satellite principle. Satellite orbital principle. A body tries to rotate in the same state of motion unless otherwise it is disturbed in Newton's law. One is circular path. Second one is the elliptical path. That is, again, it's a elliptical path. If it has to go, it has to have 29,000 to 40,000 km/h per speed. It is, if it is pushed from the launch pad, from here it is launched, and when it is pushed at this particular speed, it will go on in elliptical and circulate in the at the height of say around 320 kilometers above the thing on. There's atmospheric is very less, gravitational forces are less, so less or nil. So it has its own dynamics of rotation. Fourth one is the parabolic, wherein 25,000 miles per hour velocity, escape velocity. And one can ask, they go straight from here to moon, what will be the velocity need? Very, very, very large velocity of more than 25,000 miles per hour is needed. So this is the velocity. If you push that, give velocity that much, the satellite will go on rotate, unless it requires any extra terrestrial disturbances in terms of any asteroid hitting or solar storm is hitting or any other breaking power comes. The satellite will go on rotate. So this is the life of the satellite. When you put it in the motion, as per Newton's law, it go on rotating. So this is the gravitation. This is a typical satellite, and this is a satellite took a photo of an asteroid. An asteroid was passing very close. It took a photo, and it has communicated. This is the satellite program, and I am coming to this launch vehicle program also. And the launch vehicle, as I said, started with the SLV-3, that is the Abdul Kalam as project director, where its satellite is somewhere here. It had a 40 kilogram, and it went to 400 kilometers orbit. From 40 kilogram, we moved to the 150 kilogram augmented satellite launch vehicle, which also had the same configuration with the extra booster. And from there, we moved to PSLV. This is our workhorse with more than 50 launch vehicles we have launched, which carries something like 1,600 kilogram payload. It takes to the polar orbit. From there, we move to the GSLV, which it takes 2,000 kilogram of spacecraft, and it puts in the sun synchronous orbit. This also we have mastered, and now we have come to a Bahubali rocket that's called the Mark III, which you can put 4,000 kilogram of satellite, put it in this fairing to the sun's internal orbit, with which only we were able to launch Chandrayaan 2. So this is our launch vehicle growth scenario, and if you see,
I'm sorry,
yeah,
sir.
yeah,
What are the launch vehicles that you have worked on, sir, on these things?
all the three,
All of it.
all the.
Okay, super, sir.
So already I have told these are the launch vehicle, PSLV, GSLV, and GSLV Mark III. GSLV Mark III, I worked in the design phase, whereas GSLV, my contribution is there in the cryogenic engine. Here, what you see here is a cryogenic engine, and the PSLV, my contributions are there in the liquid engine here and here, and the instrumentation is somewhere put in somewhere here. Instruments are the wherein my contributions. So these are the launch vehicle program for the purpose of students. A rocket engine is a device which it generates a thrust by converting propellant into a high-speed exhaust gas in the form of jet, thereby imparting kinetic energy to it. The propellant can be a solid propellant, like what you fire it in Diwali crackers, which is a solid fuel. It is having a solid fuel. The another type of fuel is called liquid fuel, which is a bipropellant liquid engine, like our petrol diesel engine, petrol diesel engine, which you can store the petrol, you can store the diesel, and then an oxidizer is required, and fuel and oxidizer together. A bipropellant liquid engine is a device which generates thrust by converting the fuel and oxidizer propellant into a high-speed exhaust jet uh, of hot gas created by the chemical energy released from burning of the propellants. This is the, again, as I said, fuel and oxidizer given there's a combustion and it is done through a narrow passage called the nozzle through which the hot gas is going out. This is the when the force is going this way, there's a rocket engine. Fundamentally, it is there's a when it's a force is going, action is there, the reaction is going this side. That's how the rocket is going. Rocket engines are reaction engines. Reaction, they are called reaction engines. And for every action, the Newton's law, there's an equal and opposite reaction. So the action pushes the rocket to the top to go up. When it goes up, it has certain velocity, speed. The speed is to be increased. How best you have to increase? You have to increase to beyond 25,000 kilometers per hour. The level you have to much beyond that. We call it 13.5 kilometer per second. Like that we used to calculate. Then only we can escape and go to the orbit, which I have told. This is the rocket, how it goes. First stage fires, and first stage, and it falls down on the Bay of Bengal, and then second stage fires, and it goes here somewhere beyond Ceylon and other thing. Third stage fires, and it falls somewhere around Australia, and finally it goes to the orbit. Fourth stage, this is the rocket which gives the power, velocity. That velocity only goes to the orbit of 727 by 727 kilometers. At that inclination, it goes. This is the typical PSLV sequence. This is which you have mastered. And the first stage is solid, second stage is liquid, third stage solid, and the fourth stage is liquid. And the satellite is pushed by the fourth stage motor with a velocity of something like 11 kilometers per second. Then only it will go around with the orbit in a circular orbit. This is a mission sequence of launch abort. That is when it is going to the altitude 2 kilometers, if you want to deploy, it is an experiment for the launch abort to the manned mission. A manned mission, if it goes, it has to be aborted because of some technical reason. It is the sequence, it escapes from the rocket path. Rocket is going like that. It escapes from that and it is jettisoned and it falls in the Bay of Bengal with a parachute and a buoy. It is falling. So we choose the another important thing is sounding rockets have been launched from western coast. Uh, Satellite launches have been launched from eastern coast because Earth rotation, Earth rotation speed, we want to make advantage of that. So the rotation speed will to make advantage. We have to have a eastern coast. Then only the empty shells will fall on the Bay of Bengal. So we have taken it is above the latitude, Mediterranean line. It is above the Mediterranean, around 18 degree above, and we have to make a turn like that and go in the polar region. So we have taken a Sriharikota as a spaceport of India in 1973 itself. We are selected and developed this place. From here, they are launching ASLV, PSLV, GSLV, all the rockets are launching from here. Now we are going to have another launch pad in down south of Tamil Nadu near Tuticorin. From here, it is going to have it go straight here like that. This is the exploded V of GSLV Mark II, wherein I told this is a solid motor and this is the liquid strap-on. It gives additional velocity to lift all these rocket and the satellites here. To take the satellite of 2000 kilogram satellite to that orbit of elliptical orbit of 180 kilometer by 36,000 kilometer, it has to give a push. This motor has to, this is a cryogenic engine stage. This has to give a push. As I said, the fuel, liquid stage, I have told. The third stage is cryogenic, which holds liquid oxygen and liquid hydrogen at low temperature. The liquid hydrogen is at 20 Kelvin and the liquid oxygen is 90 Kelvin. When both the liquids are fed at high pressure, it gives a heavy thrust and pushes the satellite to the orbit. So cryogenic engine technology, which we are not having till 1995, we partially acquired from Russia, and we indigenized the rest of the part totally in India. And now the cryogenic engine we have mastered, and we with the power more powerful than what Russia gave. That engines we have made and put it in Mark III rocket. So this is the flight sequence. Already I explained. The strap-on fall here, and the second stage it goes to the orbit of 350 kilometers altitude. This is the typical flight sequence. Coming to the satellite is, as I said, I started the geostationary satellite, which rotates along with the Earth at the same speed of Earth at 36,000 kilometer orbit in the equatorial plane. We have GSAT series and INSAT series and IRNSS series. Like that, we have multiple satellites we have covered from the period of 1980 onwards. 1980 onwards. Till now, we are having our own satellites. But what happened is sometimes our satellite weight goes beyond the 4,000 kilometers. So we have to go use French rockets to launch such type of satellites. Otherwise, our own GSLV will meet the purpose of the satellite. So this is an INSAT system, and this is the remote sensing system. Remote sensing system, already I said that it can be used for agriculture, forest, rural development, urban development, and water resources. How does the water content in your soil that can be measured? The ocean development. Suppose oil seepage is there in the ocean, the seepage level can be measured. Mines, science and technology, planning emission, biotechnology. These are the uses they use for the science and technology by both state government and private sector can be used. As already I have told, these are the applications. We are using it for the last 1985 onwards. We are using emotion sensing and the land and water resource development and natural resource development. So some of the typical example I already told: distance education program, the education program to the remote area, and the telehealth, telemedicine, village resource centers, and disaster management. Village resource center means we will communicate to the village centers for the health as well as education purpose. And the disaster management, when there is a large fire or a flood in Assam or flood in some Orissa region, our satellite can monitor the disaster and communicate to the ground station so that precautions can be made immediately. This is our last two cyclones in the Orissa and Andhra Pradesh could be averted, and we could save many other lives. And this is an education network which we are using widely for the last 2 decades. This is called EduSat network from the state capitals. You can communicate both way to the satellite, and satellite will communicate to the university or schools, and the students can be benefited by this particular method. This is what right now is being privatized, and the private institutions are bringing up the educational online education system, but they use a extensive C-band or KU band transmitters in the satellites. Similarly, for the telemedicine, in a remote area where the people are not accessible to a healthcare system, to the urban super specialty hospital, they can contact through the telemedicine facility, and they get a good diagnosis and treatment through the expert panel of doctors through video conferencing as well as by the communication system. This is the national public-private partnership. It is one of this particular thing. These things are recognized by WHO and ITU, and this is some of the thing which is being well. There is an example. Delhi AIMS doctor that we contacted right from Kanyakumari at Trivandrum to our telemedicine, and they get the treatment prescribed by the doctors, and we can make use of it. This is how satellite services are being done for health. Previously, I told for education, and the third one is for the agriculture purpose. This is the village resource where the village people can be educated by tele-education, and the our village forecasting can be done, and water soil, water table can be measured, and this is how it has helped the village resource center. And satellite radar research and rescue already I explained. This is an INSAT satellite, helps the disaster. Right now, recently, a ship has been got fired in our Indian Ocean, and our satellites could give a back and warning to the ground station. So, rescue team could reach and make rescue of the system. And this is the SATCOM application, broadcasting, television broadcasting, direct to home, and the TV radio network. Here, the important point which is to be noted is, earlier our television broadcasting was using a S-band or C-band, which uses a large dish antenna. Right now, our DTH has gone to a dish antenna of a small diameter of even 2 feet diameter, which is further going to be reduced by your handheld terminals, by your telephone mobiles. Broadcasting, meteorological, imaging, and cloud mapping, and others mobile services, and these are the things which SATCOM the application can do. This is one of the typical example which we have told is IRNSS, Indian Regional Navigation Satellite System. There are 7 satellites flying over Indian territory, which beams towards the India, so that the regional navigation system can be done. We are doing by 7 satellites, whereas a normal GPS, which is there fitted in your mobile phone, is having 28 satellites sent by Americans in American system, flying all over the globe at particular orbit. So this GPS is an American system, whereas Russians are using a system called GLONASS, which uses a 22 satellites. 22 satellites we get. Some of your telephones, smartphones, if you see, compatible with the GPS or the GLONASS. Similarly, French people also sent a couple of satellites, 18 satellites. That's called Galileo. Whereas Indians, we are managing with 7 satellites entire navigation. Our NAVIC system is going to be operational very soon, and by which we can have our own navigation. We need not depend upon GPS. GPS, our own navigation, which will be a self-reliant in the technology development for the country, which is going to come in very shortly. And these are the thing which is satellite, how it can help the common man and improve the life program. And as Sarabhai envisaged, second to none. When Americans, Russian, and Chinese have gone to the outer space and gone to the moon and other planets, we also should explore the outer space and find out what's happening. So, in the solar system, we are in the third first Mercury, Venus, and Mars, and the Thor. This is not everybody. So, we also made an attempt in the Earth going around the moon. That's called Chandrayaan 1. And we went, we sent Chandrayaan 1 spacecraft, which measured first time the moon has water content in its soil. This is measured, confirmed by Chandrayaan 1. And the Chandrayaan 2 is the another mission wherein we are supposed to land and the rover Vikram, but we are not successful in this. Here, if you see Jupiter, Saturn, Uranus, these are the galaxy of solar system. And you see white spots, they are called the Jupiter belts. These are small, small, tiny particles. They are around our solar system. If you go beyond this one, this is called the exoplanet. So, these Americans, French, and Russians, they are doing experiments on the exploration of outer planet to find out whether the external planet has any resource or microbial life or any possibility of further wealth. They are exploring that thing in all this recently. Recently, yeah, an exploration has been made. Venus, Venus, which I said, which is the previous Venus is before us. This is larger than Earth's surface, and there is a possibility of life is have been found out because Venus surface is having very high temperature of something like 600 degrees centigrade, whereas above the Venus Earth surface, Venus surface, around 10,000 feet above this one, there is a gas called the phosphine, phosphine, PH3, PH3, phosphine. Phosphine is available. The indication of phosphine is there may be a possibility of life above the Venus surface. This is the finding latest we have found out. We already sent Mars. Mars is containing a lighter planet which is having carbon dioxide. The maximum, the environment is having 98% carbon dioxide. Possibility of living is very less. But below the Mars surface, there is a possibility of planet, life. That's the thing which they have found out. They have also, Americans have explored Cassini, the aircraft planet called Saturn. Saturn gas. This is a gas ring. They have gone near to the Saturn by a probe called the Cassini, and they explore what is the surface, what is the gas available, what is the spectrum, what is the light, what is the temperature. Those things they have measured. This I think I can skip because this is Chandrayaan 1, which everybody know. We sent through PSLV, it went through a G2 orbit, and after that it went to a translunar injection, and it went through, the finally a lunar orbit. It went and it landed in the lunar impact. The time permits, I will put a video on this. And this is a rover, which is planned for the Mars mission, and this is the American rover, which has 6 wheels and multiple camera, and it has 28 cameras, and the number of computers is more than 42 computers, and it is operated by not only solar power and nuclear power. nuclear powered plutonium based battery power in the you can and this Mars mission which we sent. And if you see, an interesting thing is Martian year is Earth is third planet. Mars travels further around Sun in its orbit than Earth does. So one Mars year is longer than Earth year. Days of Mars is Earth year days. It takes Mars to go and come back. So it has a temperature of minus 63 degrees centigrade, minimum of minus 140 degrees centigrade. This is the composition of the day, the cold. But whereas the Venus, which I had told earlier, which rotates, the one interesting thing is Venus is not tilting, but at the same time, Venus to cover 1 year, by the time it would not have completed one rotation by itself. Its own rotation is slower than its rotation around the Sun. That's a peculiar dynamic. This is a Cassini spacecraft sent by US. And one more experiment where people are interested about Sun. Can you do the experiment on the Sun? And India is making a program for the called Aditya. It goes near to the probe sent to Sun, measure the plasma and the corona mass ejection, CMI, corona mass ejection, like this, how much this corona is injected. This ejection related to how it goes to the space, outer space, how it impacts on the Earth. That type of study they are planning to do. Similarly, US also has the probe called Parker. They sent a probe called Parker, and they measured certain parameters. And we are planning in next 2 years to go Aditya. And interesting things, if you see, Earth has a magnetic field in north and south. This is called the north and south. This is the magnetic field. What you see by a compass, every students will be knowing. But this north and south pole is wandering. It is wandering by how? 11.20 degrees. It is not only, it is not here in the north always. It goes this way and this way. This is due to the earth crust. Inside there's a molten metal that moves and that gives an oscillation. So this wandering of the pole, Earth's magnetic field is going to be it is an issue, not only in the mainly for the ships where we use a magnetic compass. This is an issue. This is much more in the other panel. This is one of the points. When there are two planets, Sun is here, Earth is here. There's one particular point, the attraction is same. It will be null and void. Attraction of the Sun and the Earth is that's called a Lagrange's point. That's Lagrange's point L1 and L2. Similarly, there are three other points L3, L4, L5. The L1 and the L2, wherein the force of attraction by the respective thing is nil. So we try to put a satellite at this particular point, L1, and do the so at the time there will not be attraction by this either Sun or some other planet. So you can do the measurements from L1. That's why our mission to Sun, Aditya, is called Aditya L1. So we'll try to put a probe here and measure the what is happening in the Sun. So this Lagrange's point, we call it in space parlance. Lagrange is the place where say enough. You will not be disturbed. So this is a thing. And Earth magnetosphere, there's a radiation belt, and this is slightly much deeper in space astronomy. That is, it has a tail of magnetic wind, we can magnetosphere wind. So when there is a satellite goes in this region, this will get slightly disturbed, slightly disturbed. So that's we also call it a typical terminology called the panel-on radiation belt. It's the inner and outer. This is around the Earth atmosphere here and here. So this inner atmosphere, this radiation, one and the inner radiation belt, and so we have to have a satellite above this radiation belt. So there, this attraction of the inner this particle will not be. So they could go beyond Mars and beyond Saturn, and somebody has gone beyond Pluto. Pluto, they have gone beyond, and that's a planet, and it goes that it has gone to the exoplanet, and it has gone as a flyby. Flyby means it passes through the planet, not landing or anything. They have mapped Pluto's condition and Pluto's impact and the environment, and that measurement also they have done. So these are the things. There is interplanetary exploration, which is for the human interest. It is being done. But the general question is, what work is going to help data? The satellite data right now during the corona period, it was much useful for the healthcare system, integrated smart patient care system, homeland security, traffic control, manufacturing intelligence, and financial. Banking also our satellite data have been used. How it is, I will tell you. Similarly, for telecommunication, trading analysis, and search and quality, our big data analysis, that is, in coming years, satellite technology used along with the ground station, and it will be very much data will be available. This data will be analyzed, and it will it will help our living condition in a big way. You see, we are going to get the 5G technology. 5G technology is going to come, and we are going to get driverless car, artificial intelligence, and smart sensors, and robotic systems, and you are going to have virtual reality, and embedded system, and Ethernet technology. Even sitting in from your home, you can operate a device in somewhere in the far remote places through Internet of Things. That's called IoT. Internet of Things you can do. Sensors are going to come in a big way. Smart sensors. All are using the satellite data. You are using the satellite data for earlier as I said for limited use. It has a wide scope for using in our common life in terms of health, in terms of education, in terms of safety, in terms of economy, in terms of our normal livelihood that you are seeing in every day when you put the TV advertisement. You can see similar things in the future years are going to have augmented reality and virtual reality, by which satellite data, the data is going to come, the data has to be analyzed, stored, segregated, and applied to the appropriate place. This is a major task. Putting a satellite and a rocket is not a major task. Using this data to the common man, we have initiated that is geospatial data and the navigation data, which has to be stored to a healthcare system. This this corona COVID period, where geographically each person's healthcare system can be stored and given instruction to the healthcare people so that appropriate reactions can be done. If you see, as I said, these are the two things. Satellite and launch vehicle are only very small. In the coming years, this is the American budget projection for the economy coming years. It is going to have satellite manufacturing and launch vehicle. Rocket and satellite is only very small part. Whereas satellite services are going to be a big role in terms of television, telephone, broadband, aviation, remote sensing, science, and related ground equipment. Ground equipment means the 5G technology is going to come. 5G is available only in 2-3 places like Korea, China, and America. But 5G uses compared to 4G, it is 100 times faster. Uses satellite and ground-based technology, and they are linked. The satellite data and the ground-based data linked and distributed to the million people. In future, it is going to see by another 2-3 years, number of mobile services will be 3 billion users will be there, and 3 billion users will be using 10 billion devices. Each fellow will have his own mobile, each fellow will have his own laptop, each fellow will have a TV camera, all put together. One one service through which it's some 4 or 5 devices will be used. All these things use satellite data. Satellite data is going to come, and it is going to be a human revolution by means of connectivity. I'll say by means of connectivity. By connectivity, what we mean is you are you get a self-reliance and the space with man-to-man, man-to-machine, machine-to-machine learning. All these things are possible with satellite data. Along with satellite data to ease, what they do is they use drone technology or balloon technology. They take it to the balloon to the hotel level. The satellite data will come from there, and the balloon will disseminate from. So, as an intermediate relay race, they use drone technology, and harnessing of the resource, earth resources, is very much required. Strong connectivity is will be ensured. Our technology, we will be reaching a self-reliance, but still space technology, if you look only this rocket and satellite, we are far behind. Whereas the satellite services and ground equipment, we are much advanced. India has more talented people in the younger generation in terms of IT, computer science, and other ICT technology. That's why one scientist told for each yeah, every country has its own strength. America has its own strength because of its communication power and banking power. That's why they earn a lot of money and they are rich. British fellow, they are having rich because of their medical technology and their textile business. So they are rich. Japanese, they grow and their finance is much more because of their dynamism. German, they have more growth because of their mechanical strength. Gulf fellows, they have a more strength because they have oil wealth. Wherever they dig, they get oil. So their resources much more. So they are rich. Similarly, India has a full strength of its IT. India's growth is because of IT. IT means, I have already told, information technology, but it is not so. IT matlab, it is Indian talent. India has a lot of talented youth and youngsters. This talent has to be brought out, and hidden talent has to be brought out. And the hidden talent, now there's an opportunity using the space science or the data, big data analysis, or doing information technology or artificial intelligence and machine learning, or so many new technologies which are going to come, which are out of bounds of your curriculum, which are out of bounds of your curriculum. Students should learn, by which you have a lot of opportunity, by which India will become really a self-reliance. With this, I could say how the space is playing a major role in getting for the human people, livelihood expanding our livelihood, and how it is improving. So this is the message I want to communicate in this Learn Space Week of this 2020. And students not only confined to the rocket and technology satellite, and you should go for data analysis, data consolidation, and big data application. Application also. How best we can apply the data. Really, this Corona period, last 6 months, our entire economy, education, health, and our day-to-day living has been shattered by this disease. But this has given an opportunity to meet the challenges. The challenges are much more. We can explore the challenges. The unhidden talent, opportunities can be explored and used. With this, I conclude my talk. Thank you very much for listening. I'm available for any queries or questions.
Yes, sir. Sir,
Thank you.
first of all, mind blowing, sir. You know, the kind of information that you gave us, Actually, today we also had another competition. So in the competition was about a poster making challenge, and students have to do a poster which signifies the role of satellites in helping farmers and helping agriculture in India. So I think you covered a little bit of that in today's topic, and it was kind of like very nice to
Uh,
see how.
Take minute, take minute. If you want further some more thing, I can. I have one more view graph wherein how the drones using
Uh-huh,
satellite data and how
uh-huh.
it gives the agriculture farming, natural
Okay.
farming, seed testing, and
Uh-huh.
fertilizer planning, and even harvesting the crop. That I had a
Oh.
one. I think
Yeah,
I had
but
a one.
right now, I think since most of them are young children, 90 minutes is kind of like very difficult for them to sit. But we have seen almost all of them who are here being for the entire duration of the session, sir. So with that, we are very happy having you over here, and extremely once again, sir, extreme thank you so much for taking your time out and being here and talking to kids about it. So, guys, if there are any questions, I have a few questions. One child was asking,
Yeah,
Mangalyaan,
please.
why wasn't Mangalyaan launched by GSLV Mark II rocket?
Okay. GSLV Mark II is
Uh-huh.
having a launching capacity of 2000 kilogram. Actually, it was designed for 2250 kilogram satellite to put it in transfer elliptical orbit of 180 kilometer perigee, and apogee is something like 36,000 kilometers. To put it in the elliptical orbit, you need to have a velocity of something like 13 kilometers per second. To push a satellite in 13 kilometers per second velocity, you need to have such a powerful, that is 2250 kilogram mass satellite at a velocity. To push it, you need to have that much of force. So our GSLV Mark II is having the adequate capacity to put to Mangalyaan, uh, because Mangalyaan weight was something like 1850 or something like that. I think so. So for which Mangalyaan, our GSLV Mark II is adequate. GSLV Mark III is too luxury. GSLV Mark
Okay.
III is it can go take up to 4 ton,
Okay.
4,000 kilogram. So it can take. So and also the development of GSLV Mark III, we had only first trials, and the second test also was over. By the time Mangalyaan was ready for launch. So we had to use a proven vehicle of
Okay.
GSLV Mark II.
Superb, sir. Sir, and can you tell us something about the Gaganyaan mission of India's plan to send an astronaut to space, and what kind of vehicles they would be using?
Yeah, this is. I think that I should cover these things in the for students. I think. See, mainly for taking a man, safety is the first. A fellow has to be taken to the top orbit, and he has to be brought back. The students, are you aware who is the first astronaut from India has flown to space?
I think they should be aware about Rakesh Sharma, sir.
Rakesh Sharma.
Yes,
Similarly, who was the first astronaut went to space all over globally?
which I'm not aware, so probably kids would answer up. Guys, why don't you post who was the first astronaut to go into space in the chat box? Sir, you can actually close the screen share so that you can see what kids are typing down.
Yeah,
Yeah.
yeah.
So some students are expressing their thank you for the session.
Okay, okay. That's an interesting thing. The first one, uh, first is, yeah, correct. Somebody has given a correct answer. This question we asked, used to ask students. Uh, First satellite to go into orbit is Sputnik. First man to fly in space is Russian astronaut called Yuri Gagarin. Yuri Gagarin. First
Yes,
man
sir.
to land in moon is
Armstrong.
yeah, yeah. First man to land in moon is here. The student should note one particular incident. I will narrate. They went in Apollo. There were three astronauts went for the moon. The captain is Buzz Aldrin. Captain of the mission was Apollo mission was Buzz Aldrin. Co-pilot was Neil Armstrong and Collins. Collins is the orbiter who orbits around the moon. And these two people went in the Gemini Eagle and landed in moon, wherein Buzz Aldrin, captain, and Neil Armstrong, they landed on the moon. As soon as they landed on the moon, they were given a gestation period of 1 hour. They were supposed to open the hatch and they are supposed to come down. So the signal was given from NASA. Yes, bus, you can open this thing and go. But Buzz Aldrin was nervous. He was shivering. He is afraid. His blood pressure went up. His heartbeat has gone up. His sugar level has gone up. He was sweating like anything. So he was not in a stable position for 20 minutes. After 20 minutes, NASA gave a command, co-pilot, you please go. He opened the latch, went down, stepped down to the moon surface, and put the American flag and put a wave to the American president. So American president immediately told, one small step, a giant leap of mankind. And the entire history, the person first man to land in moon is now has been told Neil Armstrong in golden letters. But
And Buzz Aldrin
this
is no more.
message, what who should have got? Buzz
Buzz
Aldrin
Aldrin.
should have got. Buzz Aldrin has not got that golden chance, and he remains still a second person. And because of his fear, courageousness, his uncertainty, and what he wanted to attain the goal, he just slipped. This message should go to the student. When you want to reach a goal, you should be courageous, you are perseverance, you should be strong, and you should not be getting diverted from any of your attention. You want to become a doctor, you become a doctor. Towards that you work. And your aim should be that. If you once when you started your mind is not stable, you will lose everything. So even now, Buzz Aldrin, 92 years, he's uh, he's uh, he's attending a class for Mars. Next mission to Mars, manned mission for Mars. He is the training coach at the age
Wow.
of 92. So a golden chance is missed because of he lost his self confidence. Students should not lose his self confidence. That's the message I used to tell.
Fantastic,
So
sir.
So this message, the second part, which you wanted the question for answer is, so in 1969 itself, America sent a person to moon and stayed and brought him back safely to here, safely brought here. That is the achievement which he has made. So the main criteria is you have to send a person to the outer space, wherein no environment, hostile environment, no gravity, and remain in space, and you should bring him back safely. So you have to have a good propulsion system.
Mhm.
Propulsion system means rocket. A rocket should carry a person safely, reliably, and put it in the space. At the same time, if there is a disaster, he has to escape. He has to abort. Abort means he has to come out of the rocket much is faster than what rocket speed. Rocket goes in a particular direction. If there is a disaster happening, he should escape from this much faster. So yeah, the abort system and the hostile environment, yes, to send the gravity, zero gravity, temperature, radiation, radiation, radiation comes out of that he has to withstand, and you have to bring him back. So this technology, Gaganyaan, we are working out, and we want to have it in next 2 years' time. We have rocket. We have rocket. The rocket is the abort system and human safety. They are trying to put the 2 or 3 astronauts. How they go there, and they have to remain there for a day or two and come back. That is the mission. They go to the space. First, Yuri Gagarin has gone. From Indian side, Rakesh Sharma has gone from Russia. Now, Indian soil, from Indian soil, if you have to send a person, Indian astronaut has to be trained. The training facilities are less. So they are getting trained at Russia, and they are coming back, and they have this kapda. These astronaut clocks are getting tested, and the instruments, and we have the knowledge on the how to go to the particular direction and come back. That the dynamics we have, because we have mastered in Chandrayaan and Mangalyaan, so you can bring back. But any cars, their
Human
safety
life
is
is more
important.
important. Yes.
So our Gaganyaan, before sending a person, even American and Russia, they put a Leica. First, a living being went to space is the Leica. Before Yuri Gagarin, before Yuri Gagarin, Russia sent a Leica, a dog. It died. It died in that particular thing.
And
So
then
here,
monkey
so
was
whether
sent.
monkey was sent there. So here, we don't want to put other animals. We want to put a robot. Robot has multiple sensors. It will
Okay.
sense the environment and other thing, and it gives the get the information and communicates back to the earth. So roboid based one mission, trial mission will be done, and based on the success of this roboid, and we then second mission will be a active mission with the astronaut.
Hmm.
And we plan everything goes smoothly. We have selection of astronauts, we have selection of astronaut dresses, and the instrumentation. Everything is over, and the instrumentation and the trajectory and coming back. The simulation also has been done. Simulation, everything is done, and the only thing is they have to before taking a risk, they want to put a robot,
Okay.
robot.
Super, sir.
Yeah.
Sir, I think we are almost like 95 minutes down, so I'm not going to bother you more with questions. But I would definitely would love for you to join us one more time, maybe in the month of November
Hmm.
or December, for one more session with all our students, sir. Maybe we can just it can be an open session where students can start asking you questions, and you can answer rather than getting into a topic. I think your wealth of knowledge with ISRO, a lot of students are kind of like interested to know to pursue a career in ISRO, but they are kind of like clueless what to do, how to go about it, and stuff like that. So maybe we could touch upon those stuff next time when we meet up, sir. Huh?
Sure, sure, I agree. Sure.
Definitely, sir. So thank you so
Again,
much once again,
thank
and
you,
loved having you here, sir. Thank you so
thank
much.
you,
Yeah.
thank you very much.
Okay.
Thank you.
Thank you. Thank you. Yeah. Okay, guys. Thank you so much for being here. We'll all see next tomorrow. Meet you all with the what is this challenge for tomorrow? Tomorrow we have the science video making challenge, and on Saturday we have the Kahoot with Learning Coach. Whatever sir had taught you so far, we are going to have that in the Kahoot session. So please go through this video one more time, and please do share this video to your friends and family. Meet you all on Saturday. Remember, on Sunday we have the Astronomy Masterclass with Dr. Moi Abbas. So that's going to be another power pack session. So he is a real-time astronomer learning about galaxies collision and stuff like that. So it's going to be really good, and hope you guys have enrolled for the program. If not, please visit our webpage learnspacescience.com, and click on masterclass and do register for the program as soon as possible. Okay, so looking forward to have you all on Saturday. So see you all. Bye bye.